All right, let's see how you're doing on this one here. Very similar to the last one we just did, but the information has changed a little bit. So it says ZX is right here is 24, YZ over here is 27, and they want angle X. Once again, you notice which angle that I stayed away from. I stayed away for now from the right angle. Well, we know two sides. Again, if they wanted that other side, I could do Pythagorean theorem, but, well, that's not what they want. And so what we need to do is figure out, well, if I'm asked about that angle, where 27 is would be considered opposite. Is 24 then the hypotenuse? No, it's adjacent, because this one up here is the hypotenuse because it's across from there. And so we're talking opposite and adjacent, which means, well, is it that one? No. That one? No. That one. Again, you do have to spell it right, or you are going to have some problems. So if we're talking opposite and adjacent, we are talking tangent. And do we know the actual angle? No, we don't, but we know it's called x, so we'll do that. And does it matter if it's 24 over 27, 27 over 24? Do you think that makes a difference? Yeah, it makes a huge difference. And which way should I do this one? Should 27 be on top or 24? 27 should be on top over 24. Now, in other words, I need to get tangent away from that angle again. Just like we had to get sine away from that other angle. And if you look on that calculator, what's right above tangent is tangent to the -1, which is called arctangent. It will cancel on this side, leaving me with x, but then I have to take tangent to the -1 of the other side. And you type that into the calculator, and let's see what that looks like. And it was 27 over 24. And I should be in the same mode because I set it to degrees. It should still be in that mode. And it looks like 48.4 if you round to the nearest tenth. Okay. Once again, pretty simple. And what you just did is you found out what this angle has to be. It has to be 48.4 degrees. Okay. And then we can find the other side if we had to. And we could find that other angle if we had to. Right? And we'd be done. So it's not overly difficult as long as you learn this new step of algebra. The arc trig is what you could call it. Arc sine, arc cosine, or arc tangent. Okay. Any questions? All right. Well, we've got a surveyor apparently. A surveyor is that person that every once in a while you'll see on the side of the road with the tripod sitting out there with a little telescope on it. It says it's 130 feet from an obelisk. Anybody know what an obelisk is? Yeah, it's kind of a tall tower, kind of pyramid-like. Yeah. The only reason I used the obelisk is it was on the smartboard thing again, so I didn't really have to make a picture. It says that tower is 86 feet tall, so there it is, and we will say that is 86 feet tall. So from there down to there, 86 feet. Obviously, if you just want to make a tower on your notes, that's fine. Or if you just want to draw a triangle, that's fine too, but you might want to be careful. The surveyor's theodolite. That is actually what that thing is called that the surveyors use. It's called theodolite. Is 4.75 feet above the ground. For those of you still unsure what a surveyor is, there you go. Obviously, you do not have to sit here and draw this perfectly to scale or draw the theodolite if you don't want. A stick figure is probably good enough. It would then like me to determine the angle of elevation. Well, we've been dealing with right triangles for quite some time now, so I'm assuming that we probably have a right triangle in here somewhere. Well, he's looking this way. If he looked straight away, that's where he'd be looking, right? And then if he decides to look up, that's where he would be looking. There's your right triangle. Hopefully you draw yours a little bit better than mine. And what we know is the bottom of the triangle. We know that for sure. It says that the surveyor is 130 feet from that. So 130 feet goes right there. Is 86 feet the right side of the triangle? No, how are we supposed to figure that out then? Yeah, we know that the theodolite is from here down to there is 4.75 feet, so it really works the same over here. From here down to there is 4.75 feet, And so what is the side of that triangle? Well, it's not 86, it's not 4.75, it's 81.25. Good, you have to subtract the 2. So there's 81.25 is basically the right side of the triangle. And now, again, if you don't know what the angle of elevation is, though, you're kind of stuck. But again, it's the difference from him looking straight ahead and then looking up. And so I would say angle of elevation is figuring out that one. And if we're referencing that angle, we have 81.25, we have 130. And 81.25, we would call that opposite. And this would be called adjacent, which leads us to one that gets used a lot. That is tangent. Tangent of what, though? We don't have a letter there. We don't have a number there. You kind of got to make something up, whatever you would like to label it. What do we want to label it, that angle? R, okay. R is. Now, once again, you have to make sure that you put the numbers in the right order, though. Yeah, if we're talking about tangent, it's going to be 81.25 over 130. Once again, we have to get that trig function, tangent, away from the angle, and there's only one way to cancel that out, unless you really want to sit there and try and get this fraction by just guessing. You have to take arctangent of both sides. They cancel here. You take arctangent over there, it should give you the answer. So arctan 81.25 divided by 130. I'd say that's, you know, if you round to the nearest tenth, I don't think this example says that, but it'd be what, 32? Pretty much dead even. Again, pretty impressive that the calculator can do that for you. This is the stuff you used to go into those tables that were really small type and try and figure that stuff out. You would basically find that fraction as a decimal and where it ended up. That would tell you what the angle was. Okay. I do actually have one more that I want to work with you on. It would have been the one that we would have done on Wednesday of last week. It's the one we skipped kind of on the back of those notes, but we can definitely take a look at that right now and just throw it off to the side. It's just going to be a small triangle wherever you have room, and you can call it whatever you want. Example 4, I suppose, would be good if you wanted to do that, and just draw a right triangle, nothing too fancy. And you can label it if you want. Maybe we'll go A, B, C or something like that. And you may notice today, the one thing I never really did was give you the angle. I can give you the angle and ask for one of the other sides. It still works. And let's say this one's 30 degrees. Well, no, let's do 31 degrees. Because let's face it, if you use 30 degrees, you guys have the cheat sheet. We'll do that one for you. You don't need me to use SOHCAHTOA, but SOHCAHTOA would still work. Okay. And let's say we'll call this X right there, and I'll tell you this up here is 12. Well, one thing you should know for sure is X has got to be less than 12. Right? Because it's the hypotenuse. It's got to be less than that. And so if we take a look, we've got 31 degrees. And so we actually have an angle. And let's focus on that angle because it's the one we've got. Well, what word would describe where X is? That is actually adjacent, right? Because this one over here is opposite and this one is hypotenuse. So if we're focusing on basically adjacent and hypotenuse, and yeah, I chose that one on purpose because we haven't dealt with that one today. That is cosine. But notice what happened this time. It's not a variable anymore. I know the angle. The angle is 31 degrees. I'm not trying to find that this time. And do you agree that your calculator can do that for you? It can do cosine of 31. It won't have any problem with that at all. Type it in, hit enter, it's done. But it better equal the same thing as X over 12. Okay, do you agree there's probably some fraction out there that would give me the exact same thing as that calculator would for cosine of 31? You know, there's got to be the same somewhere. And I would look at this as dividing by 12. So what's the one way to cancel out dividing by 12? Because we want to get the variable by itself. Multiply by 12. Now watch where I multiply by 12. Out front. Did I multiply the angle by 12? No, I don't want to make the angle 12 times bigger. I want it to be the same angle. So, and you can just type it just in, just like that, 12 cosine of 31, and it should give you what X is. Okay? Does everybody have that one written down so I can go to the calculator and do it? All right. So 12 cosine of 31. 12 cosine of 31. I like to close off the parentheses on that because in case we start typing in longer stuff, you don't end up taking the cosine of everything that you type in after that. All right. And how does it know its degrees again? Yeah, it's in degree mode. All right. And so and we're expecting it to be less than 12, right? 10.3 if we round to the nearest tenth. That's believable, right? That's a possible answer. Okay, and that's exactly what it would be. It'd be 10.3. And of course, then we could go get everything else. We could go get the other angle. We could go get the other side if we had to with Pythagorean theorem or SOHCAHTOA, whichever way you wanted to get there. Basically, what's starting to happen is you're getting more options of doing some of this stuff. And I'm going to basically give you another option that's pretty popular tomorrow. Any questions?